Hello, my name is Rachel Mentzer, and in this video I'll be taking you through the basics of Latin squares. We'll be covering what Latin square is, how they are useful in terms of statistics, and how we can use them in engineering practices. The most basic definition I find of a Latin square is that they're a design for which a situation in which there is two extraneous sources of variation. So if we have rows and columns of the square used as levels of two extraneous variables, then in a Latin square each treatment appears exactly once in each row and column. These efficient designs allow us to control or eliminate two sources and nuisance variability. This also allows us to have experiments with a smaller amount of runs. So here is a basic 4x4 Latin square. As you can see, each letter appears only once in each row and column. You can think of this design as a Sudoku puzzle, where each number would appear once in each row and column. We can create Latin squares of any size as long as the general principle of keeping each treatment appears in each row and column once. As we create larger and larger Latin squares, the design typically becomes harder to create. Some disadvantages for Latin squares is that even though they're highly efficient, the number of levels of blocking variables must equal the number of levels of the treatment factor. We must also assume that there are no interactions between the blocking variables or between the treatment variable and the blocking variables. If we want to look at this in terms of statistics, we can see the degrees of freedom that the Latin square design allows. The total degree of freedom for a Latin square is typically 2 to the squared minus 1. This variation is reduced compared to other methods, but the main focus for this should be that the treatment effects and means are orthogonal to the row and column effects. Now, if we want to look at this in terms of engineering, we can typically lower our costs because we keep the variables separate and we can run fewer tests as a result of this specific design. So let's say we want to test the malleability of a certain number of materials in order to determine which is the best to use for the specific needs of a product. We can use a Latin square to design which material we think is the best fit. Here we have 5 materials of different types, and we're going to use a test to figure out which one we think would be best. Here is a Latin square that I came up with. This Latin square shows the possible results of our example in the previous slide. Using this table, we can analyze the materials and compare them against each other in terms of the test in order to more efficiently and cost-effectively choose the correct material for this job. And here are the references I used to find the information for this video. If you want to reach further into Latin squares, I highly suggest these sites. Thanks for watching.